Dr. Fitzgerald, and in this video, we want to discuss combining radicals. That's like adding and subtracting radicals, in other words. So let's look at this. Radicals, expressions, can only be combined, that is, they can only be added or subtracted when we have like radicals. And I like to think about like radicals just like I think of like terms. So I can only add 3x and 2xy because they are like terms. So in this case, let's look at some examples what we mean by like radicals. So our first example that we want to look at is adding the square root of 2 plus 3 square roots of 2. So let's look at this. My radical, my radicand, is the square root of 2. And notice the index for both problems is a 2, right? Recall there's an invisible 2 when there's nothing there. So because my index are the same and the radicands are the same, we think of these as like terms or like radicals in this case. So these can be added. And there's no number here in front of there. So that's like in that particular situation, an invisible 1 is there, an invisible 1. So I have 1 square root of 2 plus 3 square roots of 2. And my final answer for this guy is simply 4, because I add the 1 and the 3, square roots of 2. And that would be the final answer. So once again, we can only add them because they are like radicals in this situation. Let's look at another example. What if I had 2 square roots of 48 minus 3 square roots of 27? So the way that this problem is written, can this be combined? And the answer right now is no, because they're not like radicals. But we just learned how to simplify radicals, and so in this particular example, both of the radicals can be simplified such that they become like radicals. So let's see how we do that. So first we want to break down the square root of 48 and the methods that we've learned in previous examples. So how would I do that? So I want to keep the 2 out front, and that 2 is being multiplied. Notice when we don't write a symbol, that really means multiplication there. So 2 times the radical 48, but remember 48 is not a perfect square. So I want to break down 48 into 2 factors in which one of them is a perfect square. So how do we want to break down 48? As 16 times 3. And 16 is my perfect square, and 3 is the leftover part. And then let's look at the next part. Now we have 3 times the square root of 27. And once again, 27 is not a perfect square. However, I can break down 27 as 9 times 3. 9 times 3. And that's my 27, right? 9 is my perfect square. 3 is my leftover part. Now let's continue simplifying this radical. So notice this is my perfect square, so that's going to come out. So here we're going to have 2 times, well, in this problem, what is the square root of 16? The square root of 16 is simply 4. So I'm going to bring a 4 out. And then what's left over? The square root of 3. That's my leftover part. Minus 3, because that 3 is there, times, what's the square root of 9? Well, the square root of 9 is 3. So that becomes that. And then the leftover part is the square root of 3. Now a couple more steps, we're almost done. 2 times 4 is 8. Square roots of 3 minus 3 times 3 is 9 square roots of 3. Now, from after our simplifications, this problem can be simplified even more because now we actually have like radicals. We see that both of those radicals are the square root of 3. So what am I looking at once again? The radicals are the square root of 3. I have 8 square roots of 3 minus 9 square roots of 3. And this can be simplified by simply subtracting the 8 minus 9. And so 8 minus 9 is a negative 1, square roots of 3. And that's my final answer. So once again, where did that come from? Because I was able to subtract 8 minus 9 to get negative 1. And so that's where the negative 1 comes from. And then square roots of 3. And that's how we simplify our radicals. So adding and subtracting or combining our radicals. So let's look at one example in which we actually have numbers and variables as well. So let's look at that. Let's look at example with numbers and variables. So if I have 3 times the square root of 18 x cubed, and I want to add that guy to 50. Oh, square root of 50, I'm sorry, x to the 5th. Square root of 50, x to the 5th. Now we see automatically that they're not like radicals, so we know some work has to be done in this case. So that should get you excited. Let's break this down from using our previous methods. So here we want to break down the 18 as 9 times 2, and then let's break down our x cubed. Our x cubed, we need that to be x squared times x, and then plus 50, square root of 50, we want to break that up as 25 times 2, and then my x to the 5th, remember that 5 is not divisible by that 2 that's there. And so what is it that we need to do? We need to drop down 1. When I drop down 1, I end up x to the 4th times x. Now I want to rewrite this guy. I want to rearrange it just so that we can pull out. Or maybe you're getting good at this now. Maybe you don't want to rearrange it. Let's look at it. Let's try to see if we can figure out our perfect squares. Our perfect squares, I'm going to underline them. There, and in this case my perfect squares are that part. So that's what's going to come out. So let's look at this guy. 3, because he's already there. What is the square root of 9? The square root of 9 is a 3, so that has to come out. And then the square root of x squared is simply x. And then what's my leftover part? My leftover part is simply 2x plus, well, let's look at the other guy. There's nothing out front. Well, there is something up front, I'm sorry. Let's look at that. Let us erase this and get what comes out front. We have the square root of 25. The square root of 25 is 5. And then my other perfect square is x to the 4th. So the square root of x to the 4th is x squared. And then what stays under the radical? Well, what stays under the radical, once again, is that guy, the 2 and the x. So 2x. And notice in our example, we now have like radicals. And so in this particular situation, we can combine them. But let's simplify and clean this up just a little bit further before combining. So 3 times 3x gives me 9x, square roots of 2x, plus 5x squared, square roots of 2x. And once again, we notice that we have like radicals. So we can combine these. But, however, 9x and 5x squared aren't like terms. So the best I can do when combining this is say 9x plus 5x squared, and then our like radical, which is the square root of 2x. That is our final answer for this particular example. Thank you.